I've adapted a heavy duty electric hoist, building a mechanism that slides all the way along the length of this RSJ so I can lift anything here in my workshop. Let me show you how I've done it. Let's give it a try. Quite ironically, this is meant to lift heavy things. What we've got here is a heavy duty second-hand hoist. It spent its previous life on a building site and it attaches in key points to scaffolding. It's rated up to 500 kilos. When I built this workshop, I overspec the RSJ so it could take a lot of extra weight. The intention was always to have a heavy duty hoist or some form of lifting equipment that bolts on and attaches to that RSJ. But what I've come to terms with now is I don't want this to be statically mounted. I'd like to be able to move this left and right across the whole span. It gives me a little bit more flexibility and freedom when I'm using this. I'm going to try and reuse some of the mounting positions and parts on this machine, including these wheels. But having spent a lifetime outdoors, some spin a little bit more freely than others. So I need to loosen those off and take off the parts that are no longer required. Let's get some tools. So, one of the key features to make this system work is to be able to slide the hoist along the RSJ on wheels. The wheels that were already attached to the hoist were in the rond orientation, but what the wheels do have is a very small lip on the outer. In theory, if these are positioned correctly, then this should retain the hoist along the travel of the RSJ, preventing it from jumping or moving side to side. One thing that you may not have picked up so far on the video is these wheels have a slight taper to them. So the first step in the dance for me, and the first step that I need to take, is to take the critical measurements of both these wheels and the RSJ. Then I can translate this into the CAD software, which will give me a 2D view, enabling me to create the correct angle to make the bracket that's going to join to the hoist. So that's all the plasma cutting and cleaning the parts out of the way. What I've done when I've designed this bracket is the sides are going to angle in slightly, which matches the angle and the taper of the wheel, and that way the wheel should sit flat on the RSJ. So another part of this design is the small sections you can see on screen now. There are a couple of reasons why I've done this. So firstly, they form the correct angle. Secondly, they strengthen the bracket no end when they're welded in position. And thirdly, if I've done my calculations correctly, they can be used to weld the wheel mechanism to. So I used a little bit of a cheat code here to get these in the right position, flat and level, and all clamped up before I started welding. I had some 20 by 20 box section, which perfectly matched the diameter of the tube that the wheels were attached to. So I cut this down to a reasonable size, clamped it to the workpiece, and then clamped the brackets onto this. So everything is 90 degrees to each other. Right, so now that is joined safely and securely to this hoist, it is welded multiple areas and it's ready to take the weight that's required. I am going to be prepping this for a little bit of paint, so all this surface rust is going to come off. But before I get ahead of myself, there is one critical area that I've overlooked in this design process. So what I've had to do is move this bracket a little bit further over than I would have liked to. In an ideal world, this would have sat perfectly centralised in this hoist system, enabling the weight to be evenly distributed. But a lot of this weight in the hoist is over this right-hand side. And that's where a lot of the heavy goods are going to be lifted from. So you want the support in that area. But what that does is it leaves this end completely exposed. And if you imagine this going up onto an RSJ, you've got all this unsupported and it could wobble left to right. I want this to be nice and freely moving across. So one possible solution to this problem is to utilise something like this. This is just a caster I have lying around the workshop here. You can buy these from any general hardware store. They're nothing special. They don't take a lot of weight, but they don't need to in this application. So all it needs to do is support, much like this side of the bracket here, but a little bit further down to distribute and evenly glide this along the RSJ. So what it needs to do is be around this position, be able to move up and down for a little bit of tolerance. So the next step for this is to measure this up, translate that into the CAD and cut a bracket out that I can bend on the plasma cutter. So let's get to it. Right, so sometimes things don't go quite as planned. What I've done is overlook something very basic. What I've done is jerry-rig a piece of box section up here to represent the RSJ. That is sitting roughly in the right position, and this is the bracket I've made. The plan was to weld this to the hoist directly and move this up and down, which will provide some form of movement along this. Now what you've just noticed, I'm sure, as what I've just noticed when I went to weld this in, is this is living in the same place as the RSJ. So this bracket is not going to work. I need to redesign it much like this, where it comes up and out and over and still provide that up and down movement. So back to the drawing board. I'm quite happy with that. But before I give it a lick of paint, I need to test see if it actually works. And this motor and this connection are 110 volt. It's really quite common here in the UK, especially when you're using machinery outside or on building sites. So it requires a transformer. So let's plug it in and see if it works. Let's give it a try. Okay. I was hoping this was going to work with no problems. It's not the case. But what I did notice when I was assembling this and building everything around it, this little connection here isn't retracting. I think it's a switch and it tells it when it's at the end of the travel. And I actually think it's at the end of the travel. So I think some form of the problem lies in here. So let's take this apart and see what we can find out. So I'm afraid that's where this video is going to end. I'm going to strip this motor down in the next video and hopefully get this working. But at the moment, there is power going to it. There is some form of current going through it. Everything seems to be fine. But I think that's just something that's rusted on, having lived its lifetime outdoors. So join me next time and hopefully we'll get this up and running.